system is all about immunity, right? Okay? It's all about immunity, right? So when you look at the lymphatic system, right, you've got, okay, so if you have a person here,
What? Is that a hand?
It's a dendrite. Oh no, it's a person.
person.
Oh man.
It's not, but
That looks like
okay.
Slender Man.
I'm sorry.
It's like-
not gonna work.
It's one of those like
We
blow
need
up
Miss
lymph nodes.
Bounty.
You think that will work when I haven't got started yet?
The color.
It already did get started.
That's black. It's not even color.
No, the person
It looks like gum.
can't walk.
Can you redo it?
Alright, so look.
It's not an
Alright.
anatomically correct person.
Yeah, just
But I want to leave room and black. Alright, so I have the right lymphatic duct, right? The right lymphatic duct absorbs tissue, alright? Absorbs fluid,
Mine's weird.
alright? From the right side, okay, the right side of the body plus right arm, right side of the head, and dumps it into what?
Kidney.
No, what blood vessel does it dump it into? It has to incorporate it back into the blood. What? Say it. Subclavian what?
Vein.
Vein.
Artery's going away from the heart.
Vein.
You want to go back to the
Oh, I
heart.
thought-
Subclavian vein.
I got the subclavian part.
You did.
yeah. It worked.
All right, subclavian vein. All right. And then you have the thoracic duct. Thoracic duct.
What's wrong?
Thoracic duct's on this side, right? So it's absorbing fluid down both legs, right? Okay, it is dumping into the left subclavian vein. Serious question, how does purple show up? Doesn't-
Oh no, it's good.
No, you're talking to the colorblind people.
I thought you were saying different
Congratulations.
words. I don't know.
Congratulations.
They're colorblind.
Oh,
Wait, Daniel, you're
good for them.
it's fine.
Alright, okay. So your right subclavian vein, left subclavian vein. So both of them go into subclavian vein. It goes to the heart, gets incorporated back into your bloodstream. Alright? So look,
Right lymphatic goes to subclavian.
Uh-huh.
Thoracic goes to
well come
left.
closer.
Are you bad?
Right subclavian, this has been a very stressful, very
You
stressful.
said that last.
I know. Right subclavian vein, left subclavian vein. This side over here is the right lymphatic duct. This over here is the thoracic duct, right? Thoracic duct's on the left side plus both legs, and right lymphatic duct's on the right side, okay? Minus either leg. Now, you have to understand lymphatic vessels. They're just like blood vessels. They carry lymph, not blood. Okay? They don't circulate as fast. There's no heart. There's no pumping mechanism, right? So what are they doing? They're absorbing fluid from your tissues. All right? Any interstitial fluid or extracellular fluid. All that means is fluid outside the cells. They're absorbing it. It becomes part of lymph. As it travels through lymph, what's causing it to move?
Gravity.
Muscle contraction. Muscle contraction and valves within those vessels keep it from moving backwards. All right, so it makes sure it moves in one direction. Now, as it moves toward the subclavian veins, what is the lymph going to encounter?
Lymph nodes.
Lymph nodes, which are concentrated axillary, cervical, and inguinal regions. All right? So, as it enters the lymph node, just like a checkpoint, right? It's saying, what's here is not supposed to be here. Okay? Something there is not supposed to be there. What do your lymph nodes do?
Swell.
They start to swell. Why are they swelling? What are they producing? More cells. Okay? There's probably cellular growth, cellular division going on. Okay? So what does that for your blood?
It prevents.
No. What does lymph nodes do for your lymph what blank does for your blood?
Kidneys.
Don't-
White blood vessels. Who said it?
Okay. What organ? Say it louder. Spleen. Your spleen. Okay? Your spleen does for your blood what lymph nodes do for your lymph. Your lymph nodes, you just have a lot more of them. Spleen, you just have one, so it's bigger. Okay? Now, all right. So you have to have certain things to prevent things from getting into your body. This is your absolute number one first line of defense, and they're called what?
Skin.
Skin's an example of what's part of your innate mechanical mechanisms. All right, this is your very, very first line of defense. This is your skin. All right, these are things that make sense. What else?
Mechanical what?
Saliva.
Saliva,
Tears.
tears,
Is urine one?
mucus, and
It's an excretion.
nope. Tonsils would be like 1B. I'm just kind of made that up, but what else? Where's another place it can get in your body? Think of other holes in your body.
Is it hairs?
Well, you got mucus there. Lovely, huh?
Earwax.
That comes from glands in your skin. That's also glands in your skin.
Urine.
Urine.
I said urine a long time.
Yeah.
I can speak up. Be confident in your answers.
You were
No.
shaking your head, so I assumed that you heard it and said no.
No. I heard like. All right. So there's your mechanical mechanisms, right? Okay. This is all part of innate,
Mm-hmm.
right? Now you have other parts of your innate. You have innate chemicals. So let's just put innate up here. All right. You have innate. You have innate chemicals. Lysozyme. Is that a protein or lipid?
Protein.
It's an
Protein.
enzyme, so it's going to be
Protein.
It's a protein, but how do I know?
It's an
before I get
enzyme.
that word? It's a
Zyme.
zyme. What does zyme tell you that it is?
an enzyme.
It's an enzyme, and enzymes are proteins. Okay? All right? Lysozymes, complement,
What is
Okay.
that again?
interferon.
What is complement again?
Complement is the team of 20 proteins. That's the one when one gets activated, it starts activating
Oh.
another one. Okay? Each one has its own job to do. Some of them even work together to literally puncture a hole in the membrane of the pathogen. Okay? They work together, but they also help stimulate other parts of your immunity. Question?
Doesn't the interferon, isn't that produced by infected cells?
Yes, interferons. It is produced by viral cells that have been attacked by viruses to let the neighboring cells know have been attacked. Guys, if a cell gets attacked by a virus, it's done. That one cell's done. Losing one cell, not a big deal. All right? You just don't want to lose a lot of cells. All right, so look. Interferon does exactly what it says. It interferes with viral replication. That's what it does. All right? I'm not going to put interfere as part of that definition. But it disrupts, okay, or limits viral replication. So viruses will bust forth from that one cell that produced interferon, but then it goes to neighboring cells that have interferon attached to it, and it just disrupts the replication process. Okay? So those are chemicals. Huh?
Can you explain the complement again?
Complement. Team of how many?
20 protein.
20 proteins, right? Each has its own job to do. One gets activated, starts activating others in like a chain reaction, cascade event, similar to how clotting takes place in your blood, right? Clotting factors, when a cascade event takes place, right? Lysozymes are enzymes to help try to fight off.
What's a good test question to ask about complement?
Just probably a description of it, like a team of 20 proteins that function together. And it's innate, you know. All right, now let's get to cells.
Can you finish explaining lysozyme? Yeah.
What?
Fights against what? Lysozyme.
Lysozyme, it fights against pathogens. It's just enzymes to help. I don't know exactly the mechanics behind us, but it helps to fight pathogens that are trying to, that may be in your saliva, your tears, whatever. Because they get your tears all the time, or your eyes all the time, your mouth all the time. So it just helps, it's enzymes to help fight off any potential pathogens. Alright? Now let's get to cells. Alright? Cells. You have your phagocytes. What does phago mean? To eat. Cyto means
Big
cell. So it's an eater cell. Macrophage means big eater. Alright? These have dual roles. They're like policemen. They patrol. They patrol just under your skin. They patrol. Some of them like stay in certain tissues or organs. Some of them migrate. Doesn't matter. They're there to see if something doesn't belong, either a foreign pathogen or your own infected cell that is displaying pieces of that antigen on its cell surface. They do it by the MHC1 or MHC2?
MHC1.
MHC1. Any cell that has a nucleus that's been invaded can present a potentially harming antigen to the body with MHC1. Right? What presents it with MHC2?
Your
Professional antigen presenting, like dendritic cells, B cells, helper T cells. Okay, so macrophage, neutrophils. What do neutrophils do?
kamikazes.
They're your kamikazes. They're your suicide bombers. They neutralize the situation. They're first responders. First responders. All right. Okay. And you have your inflammatory cells. Inflammatory cells, mast cells, and basophils. Now, I do want you to know which one migrate and which one stay anchored. How can you remember which one stay anchored? How do you know that? Yeah, a mast is on a ship, and what else does a ship use? It uses an anchor. Mast cells anchor down. Okay, they anchor down like a best animal I can think of is a sea anemone. Okay, both the sea anemone and jellyfish both have stinging tentacles. Sea anemone can mess you up too. Sea anemone doesn't move; it just sits there. Right? What does jellyfish do? It floats around. All right, so it's like your basophils. All right, both of them, however, produce histamine, and histamine causes what reaction in your body?
Vasoconstriction.
Inflammation. Okay, all right. Now, then you have your eosinophils. Eosinophils specialize against what?
Bacteria.
Eosinophils. Eosinophils produce neurotoxins and cytotoxins that function against multicellular parasites.
Yeah.
Cytotoxins. So, what are cytotoxins?
Cell
Cellular
toxins.
poisons, right? They break down cellular membranes. They'll mess up the cells, right? Neurotoxins. What does that do?
Destroys the nervous system.
Yeah, destroys the nervous system or causes paralysis. So any type of nerve cells it will disrupt. Okay, so they function more against multicellular type like parasitic worms. All right.
What?
Okay. Now, and then you have also your natural killer cells. Natural killer cells are lymphocytes, like B cells and T cells, but unlike B cells and T cells, natural killer. B and T cells.
Yeah, I don't know.
You don't know B or T cells?
No, like, I know.
Okay, I'll get over that difference in a minute. B and T cells are lymphocytes, but they are adaptive.
Yeah.
Right? They're responsible. They produce memory cells. They're adaptive. Those two cells are what allows you to develop immunity to an illness. Right? Natural killer cells are also lymphocytes, but they're not adaptive. They're innate. So this is some of those situations. I don't care what you look like. They're come around and mess you up. But they specialize against cancer cells and viral infected cells. So what chemical do you think natural killer cell could work along with to help fight viral infections? Which chemical?
Interferon.
Interferon. Because interferon works against viral infected cells. So these two could really work well together. All right? Now, with the histamine causing inflammation, all right? Okay, you have your inflammatory response. That flow chart, remember the flow chart? Okay, be familiar with that. Inflammation, you've
Wait.
got what?
What flowchart?
Swelling.
Inflammatory response flow chart. It's also in the PowerPoint.
Okay.
Okay? What's the four characteristics? Inflammation always has these four characteristics. What are they?
Swelling.
Swelling,
Heat.
heat,
Pain.
pain, redness or discoloration.
Yeah.
Okay? This is associated with what?
Inflammation.
Oh, it's inflammation, but what has happened to you? Typically.
An infection.
No,
Injury.
not
No,
infection.
you just like
Injury.
hurt yourself.
Injury.
Yeah.
Do you get an infection every time you get injured?
I hope not.
No. Okay? Alright? Now, you combine this, however, with increased neutrophil activity. Alright? All of a sudden, increased neutrophil activity, you know something's there that's not supposed to be there, right? Alright, here come the police. Here they come. Alright? Because something's there that's not supposed to be there. So here comes the neutrophils. But the neutrophils don't just, how do they get there? How do the neutrophils get to the injured site?
Floating through the
Blood.
bloodstream.
Blood. Do they stay in the bloodstream?
Mm-mm.
No. Where do they have to move?
Into the cells.
Into the injured area. How do they get there? What process?
Diffusion.
What?
Osmosis.
Not osmosis, because osmosis is water only.
Diffusion.
Apoptosis is when a cell ruptures.
Through the lipid.
Diffusion, but it's a certain type. We talked about increased vascular
Dilation.
permeability.
What? Yeah.
Yes. Increased vascular. When I say the word vascular, what is that even referring to? Blood vessels, right.
Vascular.
Permeability. What is that even referring to? Yeah, being able to pass through. All right, it's got to be able to leave the bloodstream to get to the injured area or infected area to do any good. And then what else do you a lot of times have when you have an infection? People run a fever. Okay, fever is caused by these chemicals called pyrogens. What's pyro mean?
Fire.
Fire. Does that make sense?
Yeah.
Yeah.
Pyrogens eat your body up. Okay. So if you talk about just these four, you're talking about injury. If you're talking about these seven, now all of a sudden you've gone to infection. Okay.
First of all,
Yes.
what's the word above vascular permeability?
Neutrophils. Increased neutrophil activity.
I'm at a weird angle.
Oh, that's fine. That's fine. I know the glass. The glass.
It's bad.
It has funky reflection. Okay? Now. Alright. Alright. So let's go back up to your spleen a little bit.
And so, just to be clear, this is all part of your innate immune system?
Yes.
All right.
Yeah. From like here down. Here down. Okay. Spleen. You need to make sure you know the difference between red pulp and white pulp.
I don't.
Alright.
Wait, what is that?
Okay. Red pulp and white pulp.
Wait. What is
What
that?
type of blood vessels enter the spleen? Arteries. Well, arteries enter, veins leave. So as arteries, as blood enters by way of the arteries, those arteries are surrounded by white pulp. Okay? And the white pulp is filled up more with what type of cells?
Leukocyte?
Lymphocytes. So your B cells, your T cells, whatever. Okay? Now as blood leaves by way of the veins, it's surrounded by red pulp, which is surrounded with macrophages. I'll come back to this in a minute, and it kind of makes sense. All right? Now, let's go over to adaptive. Sorry?
What day did we cover the spleen?
I don't know.
remember.
Okay.
Long time ago.
I'm pretty sure I missed it.
It was in. No, it wasn't. Just kidding. Yeah, I think it was. I don't remember this.
People have been using the markers.
I don't like doing this with the colors.
Adaptive.
Mm-hmm.
All right. So adaptive. What is the good thing about adaptive?
It
What?
can increase your response time. to-
Yeah, it gets stronger every time. Is that always good?
No.
When's it bad?
When
Like
you
a
are
bee
allergic
sting.
to something.
When you have an allergy. When you have an allergy, okay? We didn't talk about delayed and immediate hypersensitivity. Hypersensitivity is another word for allergy. And I'm only going to mention it today because it's relevant to you. Because how many of y'all have allergies? It's relevant. Okay, that's all. If you're allergic, who's not allergic to poison ivy?
I assume we all
Just
are.
like a-
No.
I don't know.
My brother and my dad were not. That's why my
I
brother
don't know.
wrestled with me when I was about 8 or 9, wrestled me into a poison ivy patch. And then next day was laughing at me. Kid you not. I was so mean.
My dad is really bad with he reacts really bad to poison ivy, but the same places that I walk, I don't get it.
You might be resistant to it. My dad was
I've never
resistant
had
to it.
it before.
Yeah.
I think so.
I just like
When
kind
did
of don't go into like bushes. When I was young.
I mean, I just go in bushes and there's no poison ivy.
Oh.
Okay. All right, so let's look at B cells for a second. All right, so you have your B cells. All right. Then you have your T cells.
Yeah.
All right. Now, if you have it, here's a cell. If you have an antigen just sitting outside the cell, that's what a B cell is going to attack. Okay? That's what a B cell is going to attack, right? Okay? Now, here's the thing about a B cell. Two, the very, 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 very beginning of an adaptive immune response. This is what happens. Antigen binding receptor of a B or T cell binds with a foreign antigen. When that happens, it triggers an adaptive immune response. Okay? Now, does the B cell start dividing right away?
No.
Or the T cell start dividing right away? No. We'll come back to that in a minute. T cell, it has to bind
To an M.
with a processed antigen being presented by an MHC1
Yeah.
because this antigen's gotten inside the cell. See, this one's is outside the cell, this one's gotten inside the cell, and then that cell presents a processed antigen on an MHC1.
Okay.
Is the
Question?
So earlier you said when an antigen or antibody attacks a cell, it's pretty much done for. How does it have
Not
time?
antibody,
Oh,
antigen. If a virus or something gets
Yeah.
into the cell and is attacking the cell, that cell is going to die. Okay?
But it just lives long enough to present it.
Lives long enough for it to present it, yes.
Okay.
Okay?
Bob, can you repeat what you said about the T cells? They will proceed by an antigen process.
Okay. All right. So for a T cell or B cell to be activated, it has to be just a specific B or a specific T with just the right antigen binding receptor. In other words, it has to have the right key. You're not going to get in a door if you don't have the right key, right? So, and there's like hundreds of keys on each B and T cell. Not every B and T cell is exactly the same. So you might have this B or T cell that has hundreds of keys, and you have another B or T cell that also has hundreds of keys, but there might be a lot of slight differences. That's what enables some B cells to react and other B cells not to. Okay? So, if the antigen's gotten inside the cell and infected the cell, that infected cell is going to present that processed antigen on an MHC1 protein. All right? So here comes T cell, or the B cell binds to it that's just hanging out outside. All right? Now, what are both of these waiting on? I'll tell you what they're waiting on. They're waiting on a helper T cell. Now, can the helper T cell help yet?
No, it's got
What does it have to wait on?
proliferate. Protein.
A macrophage.
Macrophage.
It has to eat it.
Does a macrophage care what you look like when it engulfs you?
No. It's gonna
Does
eat
not care. Doesn't care. Alright? With macrophage, after it eats it, it also presents it on a MHC. Well, what type of MHC is this? MHC2, because it is a professional antigen presenting cell. It's a professional. Go back and watch those videos. The guy says, well, does that mean there's such thing as amateur? Well, yeah, there kind of is, right? That's the ones who just get infected, all right? So helper T cell, it's kind of the same thing, guys. It also has to have the right antigen binding receptor. Okay? Now, there are chemicals involved. When this binding takes place, this can't be just any helper T cell. All right? When this binding takes place, interleukin. This is like aphrodisiac for cells. All right? Y'all know what aphrodisiacs are?
I do know what that is. Is that like
aphrodisiacs like love for
potion.
couples? Yeah.
Oh, yeah.
Right. All right. So look. So interleukin 1 secreted to the helper T cell. Helper T cell wants to be sure, just don't want to start dividing just for the sake of dividing. So a helper T cell secretes interleukin 2 to who? Itself. Then it starts dividing.
It secretes something.
Yeah. It secretes it from the inside and it binds to receptors on its membrane.
So how is that the helpful process?
How does it help this process?
No, I mean it seems like interleukin 2. It's like a self-confirming bias.
It's kind of like a safety check, somewhat.
But does it ever not bind to itself?
It secretes enough of it that's going to happen. And there's probably polarity charge differences that kind of attract it, kind of like sperm cells are attracted to egg cells because of differences in charges.
But if it always secretes enough, how is it a safety check? If it's like an infallible process.
I don't know. I don't understand to that depth. But I'll tell you what, I would love to take an immunology class. That would be so cool. All right, so look.
Yeah.
So helper T cells start rapidly dividing. This process is known as proliferation. I'm not going to ask you what proliferation is, but proliferation might be in a test question. Does that make sense? You hear proliferation, it just means rapid cell division. That's it. All right? So again, here's this B cell and T cell just kind of hanging out. They have bonded to a processed antigen or a raw antigen with just the right antigen binding receptor, and they're waiting. They're waiting for a proliferated helper T cell. Okay? Now, this macrophage, though, what you need to understand, it had to engulf the same foreign antigens that these guys are bonded up with. Does that make sense? Okay? So it secretes interleukin to helper T. Helper T cells secrete interleukin back to itself. The proliferated helper T cell will then go bind with a T cell or a B cell. And then it secretes interleukins to a B cell or T cell. Now there's also these cells called dendritic cells. We didn't get into that, and I'm not going to. So just, if you have questions about dendritic cells, don't worry about it. Dendritic cells, if I'm not mistaken, is more associated with T cells. But again, don't worry about it in case you come across that. All right? So interleukin is going to be secreted from the helper T cell to a T cell or B cell. Now they start dividing rapidly.
Is this
okay?
interleukin 1 or 2?
Doesn't matter.
Okay.
I'm not sure. That's another way of saying I'm not positive. Don't worry about it. Okay? All right. So they start dividing like crazy. They're like rabbits. Actually, they're dividing faster than rabbits. They're like fruit flies. Wait till you take genetics in college, and you have to cross fruit flies.
Like a what?
Fruit flies.
What about?
The crossing.
They have very large chromosomes, and they only have 4, so it's relatively easy to study. And you study their different traits. Anyway, all right. So when B cells divide, they divide into 2 major types of cells. They divide into plasma cells, and what do plasma cells form?
Plasma.
No.
Antibodies.
Antibodies. How do they know what the and remember antibodies are Y-shaped, right?
Yeah.
Right?
Wow.
Good question. The V portion is called the what? The V portion is called, what is that?
Oh my god.
Stop me. What do you not understand?
Bindings. You lost me at like when they made like interleukins and stuff.
Okay. The first time or the second time?
I'm kind
I
of
understand.
lost.
I'm getting it.
I'm good, but
I don't know what's going
I'm
on.
confused. Wait,
All right.
Alright, let's slow down. Slow
No,
down.
I
Let me
didn't
get a
say
TO
on, but
explanation. Y'all ready?
Stand up, stand
Y'all
up.
ready?
Explain.
Y'all ready? All right.
I
Geo.
get
So
this.
this is what happens, right?
R
This happens. The B cell is gonna attach to an antibody,
R
Antigen.
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 Yeah, don't get that backwards.
Antigen, and then the T cell is gonna attach to it. MHC1 that was processed by a cell and it presented it. And then what's going to happen is it's going to wait on a helper T cell, and the helper T cell is going to come, and then the helper T cell has to wait on the macrophage to come. But when the macrophage comes, the macrophage is going to secrete interleukin and send it to the helper T cell.
But only after they bound it here.
Yeah, and the helper T cell has to basically secrete interleukin to take it back in.
Interleukin 2.
Yeah. What is the macrophage? Does it eat the...
No, macrophage eats the processed antigen.
Yeah.
Okay.
So everything's
the
responding.
processed antigen or that antigen?
Well,
Which
either
one?
one.
Okay. All right, good question. It could eat the raw one. It could eat the raw antigen, or it can eat a cell that's presenting that raw antigen.
Okay.
It sees it, it's like, yeah, I don't got anything to bind without the... All right, and then it's gonna present that processed antigen.
All right, then. After you get the interleukin,
I'll get you a promise.
then the helper T cell is going to come to either the B cell or the T cell. And
Or
it's gonna-
both.
Yeah, and it's going to secrete interleukin again. And when it secretes interleukin, they're going to divide. And when it divides, the B cell goes to plasma cells, which then turns into antibodies. And that's when we got to the Y.
Boom. Good?
Good job.
Sometimes students can present it like, I would have been lost. But it's okay, because everybody hears different things, okay? Now, I was going to say, B cells respond, when they proliferate and divide, they divide into plasma cells, and also, what? What allows it to be adaptive? What is being formed that's allowed? Memory cells.
Yeah.
Memory B cells. Okay? Alright? Go back to the antibodies. Remember the B part? It's called the variable. What's variable mean?
Like it
Not for sure.
just
It's various.
happens.
Alright? It's different.
Yeah.
This is what makes, everybody with me on this? This is what makes different antibodies different. That's like the key part that you put in the keyhole. It's different between keys, right?
Mm-hmm.
That's what's going to bind with the antigen. This part down here is called the constant. That is what's going to help promote other parts of your immunity. All right? Okay? Jade, what was your question earlier?
Oh, he answered it.
Good. Yes.
Okay. We had this question in AP Bio, and it was like, if you no longer had B cells, what would happen?
If you no longer had B cells,
Wouldn't you?
you wouldn't be able to produce antibodies, and you'd still have adaptive immunity because of T cells.
Yeah.
But if those antigens never got into the cells, you pretty much.
Isn't it worse to not have T cells than
Oh
not
yeah,
have
that's
B
why.
cells?
Look, that's why HIV is so bad.
Yeah.
Because it not only destroys T cells, it destroys helper T cells as well.
Uh-huh.
So you're basically rendered without any adaptive. Because even though you have your B cells,
Yeah.
there's no T cells to help stimulate its
But then
growth.
if you lose your B cells, you lose your B memory cells. So then every
Yeah.
time it's like a new process.
Yeah, but except you're pretty much just relying on this.
Yeah.
Okay?
Okay.
Unless it's something that you can get outside, or if it gets inside, then your T cells help. Yes?
What's the relationship between B and T cells?
Not much.
The fact that they both are adaptive and they both produce memory cells, but they function differently. It's almost like you have FBI and CIA. You know, they both have special jobs. They specialize in different things. They don't really work together very well. That makes sense? Helper T cells are called helper T because they have similar proteins on the outside of the cell membrane than T cells. But they do a completely different role. All right? And it's what helps bridge the macrophages, the B cell or macrophages to the T cell. Okay? So, let's go back over here. All right? So, adaptive, your B cells, your plasma cells, which are producing the antibodies, your memory B cells. T cells, they proliferate into what types of cells? Cytotoxic, which produce cytokines, which are chemicals, but they also can do cell-to-cell killing. It's like hand-to-hand combat, right? They just go up, killed you, right? All right? Thank you. All right? And also memory T cells. All right? Now, let's talk about allergies real quick. Anybody allergic to bee stings? All right. So if you get a bee sting, how quickly does your body react to it? Fast. You know why? Do you know why B cells? I just told you the answer. Okay. You know why she reacts really, really quick? That's called an immediate hypersensitivity. Why? She has antibodies flowing in her bloodstream. Not in her bloodstream, in the plasma.
And antibodies?
Antibodies outnumber T cells like probably 1 billion to 1. So if she gets stung by a bee, that venom in the bee sting causes immediate reactions. Antibodies rush there, goes. Okay? What about an allergic reaction to poison ivy? When you get the rash?
Next day.
Usually the next day. Why? The oil that produces the response from poison ivy is an oil. It being an oil, does it go?
It takes time to secrete.
It actually gets into the cells. So your antibodies are not going to react to it. Okay? Your antibodies are not going to react to it. Your T cells are going to react to it. Okay? Alright? So, So look, everybody up here. Alright, so your T cells takes more time. Remember, antibodies they outnumber T cells a lot. So it takes more time for T cells to get there. They respond to the cells that have absorbed the oil, right? They start destroying those cells that have absorbed the oil, and that's what causes rash. That's called a delayed hypersensitivity. Okay? Maybe they'll fix my door. Okay, so that's the difference between immediate and delayed hypersensitivity. All right? Now watch this. Let's go back over here to the spleen. Look at this. So the spleen, as blood goes into the spleen, it's encountered with lymphocytes. What type of lymphocytes? B cells or T cells? Okay? So just imagine this. Where's your spleen?
Over here.
Left side, right here. Okay? You had mono, right? Your spleen was swollen, right? Where does the monovirus reside? Your blood. Blood goes into and out of spleen. T cells and B cells came across that virus. They started mass reproducing. That's what caused your spleen to swell, right? Watch this. Y'all think, okay, all right, if all that's happening, don't you have to wait a while for a macrophage or helper T cell to get there? But think about this. If blood goes into your spleen by way of the arteries, lymphocytes bind to that virus, right? And as blood comes out, macrophages are sitting there waiting on it. And so now it starts engulfing some of those infected cells and maybe the viruses that sit outside. And so this is right there, so it can start happening a lot faster. Does that make sense? In the meantime, you're sick, right?
Does it not make sense to, like, the blood vessels, though? Like, all that stuff, like, all the blood, like, makes no sense for the symptoms, so.
What do you mean?
Like, I had, like, a sore throat, like,
That's just part of the inflammatory response. And because it's systemic, remember this is all in systemic. That's what associated with infection. This is local. This is systemic. So it's going to affect more than just that area. All right. If you have a sprained ankle, you're just going to do that. It's just going to be right there at the ankle, right? But if it's systemic, it's going to affect your whole body. Okay. All right. Last thing on this part right here. Okay, and I'll get some questions. All right, so you're going to have to know very specific examples of innate, triggering, innate immune responses, innate, triggering, adaptive, adaptive, triggering, adaptive, adaptive, triggering, innate. Guys, it's not that difficult. Watch. So let's talk about innate, triggering, innate. All right? Complement. That's innate. Some of the proteins in complement can stimulate mast cells or basophils to secrete histamine, which causes inflammation. Is inflammation adaptive or innate?
It's innate.
It's innate. That's an example of innate, triggering, innate. Now, I don't want you to say complement causes inflammation. You can go a little further than that. Okay? Specific proteins in complement can stimulate mast cells or basophils to secrete histamine, which causes inflammation. That's innate, triggering, innate. Question?
Is this our FRQ?
It's one of them.
Okay.
Now, what about innate, triggering, adaptive? That's even easier. All right, I'm losing some of you up here. So, is a macrophage innate or adaptive?
Adaptive.
It's innate.
It's innate.
I'm done.
Doesn't care what you look like. Doesn't care. Macrophage engulfs a foreign antigen. Encounters a T cell. Secretes interleukin 1 to the T cell. T cell secretes interleukin 2 to a cell. Starts proliferating. Is helper T cell adaptive or innate?
It's adaptive.
It's adaptive. So that's an example of innate, triggering, adaptive. All right? Innate, triggering, adaptive. What I say?
You said that.
Innate, triggering, adaptive.
That's an example of innate, triggering, adaptive. All right?
Yeah.
So macrophage engulfs a foreign antigen. Okay? That's the innate part. Encounters a helper T cell, secretes interleukin 1 to it, and then the helper T secretes interleukin 2 to itself, starts proliferating. That's innate, triggering, adaptive. All right? What about adaptive, triggering, adaptive? Helper T cell encountering a B cell that has bound with an antigen or T cell and secretes interleukin and causes it to start proliferating. That's adaptive, triggering, adaptive. Okay? Finally, what about adaptive, triggering, innate?
Would a helper T cell talking to a macrophage count?
Wait.
No. Here's the best one. Here's
that.
one.
Something makes you pee.
You're skipping ahead a couple of units. Not a couple of units, a couple of times. Antibodies. Is antibodies adaptive or innate?
What is
They're adaptive. There are places on the constant portion of the antibody that can bind
Wait,
to a mast cell or basophil. Wait, what, Jess?
You lost me.
Okay. Antibodies.
Okay.
Mm-hmm.
Is it adaptive or innate?
Adaptive.
Adaptive. Where's the constant?
At the bottom.
That's the stick part. There are places on the constant that will bind to a mast cell or a basophil and trigger it to secrete histamine for inflammation. That's adaptive, triggering, innate. Cytokines are chemicals.
Wait, and then they trigger a histamine. Wait.
Histamines cause
They
inflammation.
stimulate it to secrete histamines, which causes inflammation.
Okay.
Cytokines are also chemicals that come from T cells, which is adaptive. They can do the same thing. It can also trigger inflammation. There's also a place, if you look at this structure in the book, all right, and I don't care that you know that structure, but there's also a complement binding site that binds to certain complement proteins and triggers a complement reaction. Is complement adaptive or innate? Complement's innate. Okay? Yes?
You said cytotoxic T cells cause inflammation. They do that through the mast cells and basophils, or just do it
Well, they
directly?
secrete the cytokines.
Okay.
And cytokines are chemicals that can help promote.
The
Were we
mast
supposed to
cells.
go this long? 2:30?
It's okay. It's okay.
Because we got to review for the quiz tomorrow.
Yeah, I'll do that too.
Okay.
Do that too.
Wait, what?
Yeah.
Guys,
That's everything for the lymphatic, right?
yeah, pretty much.
Can I take a
Okay.
picture of that?
Now look, guys, big picture. If you get up here and you start studying everything like this, and you don't understand how it all works together, it makes it so much harder. When we study, like, okay, what is your lymphatic system what is it trying to accomplish? It's trying to accomplish or protection against anything that would try to harm you internally. Okay? The best analogy is like security forces of a nation. What's some forces that helps security or secure America?
The Federal Bureau.
Okay, you got FBI, you have CIA, you have NSA. I would put them more on the adaptive side. I would put things like police force,
Fireman.
firemen, maybe even general military. I might put over here. But like your Navy SEALs, your Army Rangers, I'd put over here. But the better that those security forces work together, which is not always so great, to be quite honest, okay, it's probably better than most places in the world. But the better they work together, the better security is put in place, right? Okay? This is kind of how your body works. It has to work together. All right? And understanding the different pieces and places of that working together. Okay?
Can we take
Yeah, you take a picture.
Just so we can send that to you, please.
Kai, slide it in the chat.
All right.
Slide it in the chat.
I'm just gonna text it to you.
Let's take a deep breath.
Wait. We're supposed to still go through that?
Yes. Don't get you ready for that quiz tomorrow. Okay? All right.
Man.
I'm about to erase this, yes?